Okay, I hear the recording in progress. Share the screen. Okay, I'm changing the homework a little bit for 6.2. Skip the last two problems. So skip problem 33 and 35. So I guess that should mean we only go up to 31, I should put here. Okay. So all that's going to happen today is I'll show you the quiz, do a few more parabolas, introduce the ellipse, and that's about it. Okay, no school tomorrow or Friday for Thanksgiving. Everybody have a nice Thanksgiving. Quiz is due at 11:59 p.m. tonight, and then we don't meet again until next Monday, at which point we only have 2 weeks left. Okay, so remaining calendar, we're just on schedule, finishing 6.2 today. Okay, and you get the quiz. Holiday tomorrow and Friday. So Monday and Tuesday, 6.3 is on the ellipse. I'll go ahead and write it in now, which I may introduce today. Then we have the hyperbola to do. We have one last quiz. And then we have something called parametric equations. Okay, again, plan on our last regular exam to be Thursday, not Friday. So Thursday the 6th. I'm not promising you I'll give it back to you by Friday, but I'll give you at least the solutions so you can study for the solutions in terms of the final exam, Monday the 13th, 8:10 to 10:40. Okay. And I'm saying this just because I'm supposed to. I do have office hours Tuesday, Wednesday, and Thursday of finals week, even though our final would already be done. Final exam, it's 8:10 to 10 a.m. And it's a different Zoom link. So if you really want to catch me, send me an email, tell me, and I'll give you the Zoom link for office hours. I'm guessing most of you don't need that by that time. Okay, so let's get ready for the quiz. So get your cell phones out, or be ready to do a screenshot. Okay, give the vertex, focus, and directrix as each parabola and graph. Okay. I can go ahead and share. You literally have one of each type. One parabola opens up, down, left, and right. Okay, some hints. This one is squared in x, but not in y. This one is squared in x, but not in y, and there's a negative. Squared in y, but not in x, and a negative. Squared in y, but not in x, and a positive. That should be a dead giveaway. So make them all look like x squared equals 4py or negative 4py, or y squared equals 4px or negative 4px. That'll give you the p. These two are clearly no translation, so the vertex is the origin. Here, you should know the rule. Where's the vertex? And this one you're moved, well, you moved only for y. I guess you don't have to move x. And that's pretty much it. Okay, it should be fairly easy. Look back at the notes. Again, there's literally one of each type, one that goes up, down, left, and right. You figure out which one is which. Okay. Number 1 and number 4 have only positives. That should be a hint. 2 and 3 have negatives. That should be a hint. 1 and 3 are squared in x and not in y. That should be a hint. 2 and 4 are squared in y, but not in x. That should be a hint. I gave you very nice coefficients, no fractions. 16, 8, 12, and 4. They're all divisible by 4, so you can't get much nicer than that. Okay, so give me the vertex. These are easy. The vertex is at the origin. These are translated because of the parentheses stuff. Okay, and focus and directrix. Remember, for the directrix, you need to give me a line, x equals blah, 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 or y equals blah, blah, blah. Okay, so that should be it. I hope it's fairly straightforward. Due at 11:59 p.m. tonight. And there we go. Okay, so I'll make this disappear. All right, I'm going to go back and finish up some parabolas from 6.2. Okay, problem 23. Focus is -2, 2. Directrix is y equals -2. So focus is here. Directrix is here. If I go midway between the focus and directrix, I get the vertex, -2, 0. And that tells me the p, the focal distance, is 2. 2 units to either the focus or the directrix. So that tells me it's opening up. That's x squared equals 4py. But there's a translation of 2 to the left. So it's x plus 2 squared equals 4py. The p is 2. So x plus 2 squared equals 8y. And just leave your answer like this. The idea behind the problem is not to multiply it out. Don't multiply it all out. Just leave it like this. Okay, 25, the vertex is negative 2, 2. And the directrix is x equals 2. So focus is here. Vertex, directrix, that means the p is 4. So if I go 4 units the other way, that's the focus, negative 6, 2. And now that I know the focus is always on the inside of the parabola, the curving has to go like this. So it's opening to the left. Opening to the left means y squared equals negative 4px if there were no translation. Again, translation means to move. Okay, opening to the left, y squared equals 4px. The p is 4. And the translation, so the vertex is negative 2, 2. So x gets replaced by x plus 2. Y gets replaced by y minus 2. So y minus 2 squared equals negative 4p x plus 2. That's for a parabola opening to the left, right? So that's y squared, and there's a negative. So translation means y minus 2 squared equals negative 4p is 4 x plus 2. So y minus 2 squared equals negative 16 times x plus 2. And there we go. Okay, finally 29, and then I'm done with the section. Which means I can completely knock off 6.2, skip 33 and 35. So we're right on schedule, pretty much. Okay, 29, the vertex is negative 2, 2. Focus is negative 4, 2. So vertex, focus. So that tells me the P, the focal distance is 2. I go 2 the other way, draw a line, a vertical line. So the directrix is x equals 0. That's another way of saying the y-axis. Once again, we're opening to the left. Opening to the left means y squared equals negative 4px. The p is 2. And then I count for the translation. Y should become y minus 2. X becomes x minus a minus 2 or x plus 2. So y minus 2 squared equals negative 4p x plus 2, or y minus 2 squared equals negative 8 times x plus 2. And that's pretty much about it. Okay, folks, I'm now officially done with the parabola. I literally think I've done more than 70% of the homework. I mean, there was a time where I was literally doing all of them. Okay. And did everything else from there. Okay, I'll just give a brief introduction on the ellipse, and then I'll quit and let you work on the quiz. Okay. So ellipses, what is an ellipse? Page 327, here's a formal definition. You don't need to memorize it. You shouldn't write it on your cheat sheet. But in case you're wondering what's so good about the ellipse, why you even have it. An ellipse is a set of points in a plane for which the sum of the distances from two fixed points is a given constant. The two fixed points are the focal points. Okay, we will say focus or foci. Okay. One focus, two foci is the plural. Plural of foci is plural of focus is foci. We don't say focuses. Okay. And the endpoints of the major axis are the vertices. One vertex, two vertices. Okay, again, so the plural of vertex is vertices. We don't say vertexes, but vertices. Okay, so one focus, two foci, one vertex, two vertices. Okay, so that's our English language lesson for the day, I guess. Okay, so if you give me a distance, let's say 10, this plus this is 10. This plus this is 10. this plus this is 10, or this plus this is 10, or this plus this is 10, and so on. Okay. One way you can think of it is, you might have seen such a thing. Hold these two pins down on a piece of paper, have a string of a certain length that's longer than the distance from here to here, and make a taut. So you can imagine I have a string, right, like this, and just hold the string. I mean, the string doesn't change length, and just swing it around that way, and swing it that way, and then do the same thing below, and that's how you can draw the ellipse. Okay, so you have 2 points and a set distance, a string that's longer than the distance from here to here, and just kind of swing it around like that, and like that, and like that, and you see that you have an ellipse. Okay, and then I'll give you my version of it. Okay, so you have 2 foci. Remember, for the parabola, it was determined by a focus and a directrix, a point and a line. An ellipse is determined by 2 points and a number. Okay, the sum of the distances from the 2 foci is the same. So whatever that distance is, this plus this is the same as that plus that, 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 and so on. The 2 endpoints of the major axis, the larger axis, are called the vertices. Okay, so we have 2 foci, 2 vertices. The 2 foci are always along the major axis. Okay, so the vertices are here. These 2 points make up a minor axis. These two we don't give any special name to them. Okay, so minor axis, major axis, which kind of makes sense, bigger, smaller. So here's focus 1, focus 2, vertex 1, vertex 2, major axis, minor axis. Okay. Now, we will have occasion to call letters for this. So if I'm centered at the origin, okay, the distance from the origin to either focus, we use C now. I know that we use P for the parabola. I guess one way to remember is P for parabola, but for the ellipse, we use C. Okay, jumping ahead, for the hyperbola, we also use C. This is B. This distance from here to here is A, which also matches this distance, believe it or not. Okay, you can show that. And it looks like we have a nice Pythagorean relation. A squared equals B squared plus C squared for the ellipse. Looks like A is the hypotenuse. Okay, now be careful. You're probably used to saying A squared plus B squared equals C squared, which is true for the Pythagorean theorem. But in this picture, it isn't C that's the largest. A is the largest, so it stands alone. So A squared equals B squared plus C squared. Okay, in this particular picture, it looks like the common distance is 2A. If this is A, this is A, it's 2A. And among other things, that means this distance from here to here, okay, we know this is 2B, minor axis. This, believe it or not, is also 2A. Okay, let's take this point over here. Since this is a point on the ellipse, this distance plus this distance has to be 2A. But because of symmetry, if you look at this, that matches that. So if I replace this with this part here, that means this plus this is also 2A, which means the distance from here to here is A. So this is going to be A. You don't have to write any of this down. It'll become apparent once we start doing problems. Okay, but this is A. And this is also A. Okay, so you probably want to put this on your cheat sheet. A squared equals B squared plus C squared for the ellipse. If we were meeting face to face, I'd make you memorize this. The last time I taught, I made him memorize it. But you can just go like that. Okay. Give you what they have in the text. All right, so I've given this to you already. They go over the derivation of the formula. You don't have to look at it, but in case you're wondering how did they get that, they actually use the distance formula from that point Pxy. distance from there to there, plus the distance from there to there. They worked all of that heavy-duty math out. You can look at it or not. I'll just give you the result. Okay, for ellipse bulging this way, x squared over a squared plus y squared over b squared equals 1. Here's the picture. A, major axis, minor axis. These 2 points are called the vertices. These 2 points, they don't call it anything. These two are foci, F-O-C-I. Okay. A, B, C. A squared is A squared equals B squared plus C squared. Now, the other kind of ellipse that we're going to study is one that's bulging vertically. So whereas you had 4 different kinds of parabolas, right? 4 parabolas opening up, down, left, right, just like on the quiz. One is up, one is down, one is left, one is right. For the ellipse, there's only 2 types. It's either bulging horizontally or vertically. Okay. Now, if they write it like this, I don't really like it that way. I'm going to leave x first. I mean, x is before y in the alphabet. Okay. So I'm going to write x squared over b squared plus y squared over a squared equals 1. Okay. But in any event, a tells you how much you go in the larger direction. B is the smaller. Okay. The number underneath the x tells you how far you go left and right in the x direction. The number underneath the y will tell you how much you go vertically, up and down. Okay. So the picture looks like this if it's bulging vertically. These 2 points are then going to be called vertices, endpoints of the major axis, minor axis. And now here's the picture. B, C, A. Notice the 2 foci. The 2 foci are always along the major axis. Okay, so they have this. X squared over a squared plus y squared over b squared equals 1. That's this one. You can put it in a cheat sheet if you wish. This one, albeit true, I'm going to write it where it's switched, and most books have it switched, where x squared always comes first. X squared over b squared plus y squared over a squared equals 1. Okay. This whole thing and this whole thing swap. That's going to look like this. Now, how can you tell which way it's bulging? You can tell by the numbers. Whichever of these underneath here have the larger number, that'll tell you which way it's bulging. So if this number is bigger than this number, it goes like that. If this number is bigger than this number, it'll bulge like this. What happens if they're equal? Like if it's 25, 25, well, you actually end up with a circle. You go in the same amount left and right as you do up and down. Okay. So that's what's happening. So a little bit more of my picture here. All right, for an ellipse that's bulging horizontally, A, B, C, you can put this on your cheat sheet if you want. And this is only centered at the origin. So vertex 1, vertex 2, negative A0, A0. Focus 1, focus 2, negative C0, C0. Endpoints of the minor axis, 0B and 0 negative B, they're not given any special names. So the equation of the ellipse is x squared over a squared plus y squared over b squared equals 1, where a is bigger than b. The major axis is 2a in length. Minor axis is 2b. There's a b, there's another b. And it looks like we have a squared equals b squared plus c squared for the ellipse. Foci are always along the major axis. Okay, here's an example. I just made it up. X squared over 25 plus y squared over 16 equals 1. Okay, this is a squared, so a is 5. You take the square root of this number for a, square root of this number for b. A is 5, b is 4. Plug it in here. It's your 3, 4, 5 triangle. So c is 3, right? This is going to be 25. That's going to be 16. 25 minus 16 is 9. Square root of 9 is 3. So the picture's kind of cluttered, but here's what you got. Negative 5, 0, and 5, 0. So in the x direction, left and right, I go 5. Negative 5, 0, 5, 0. Those are the vertices. Up and down, I go 4. 0, 4, 0, negative 4. What do we call these points? Nothing. C is 3. 3 to the left, 3 to the right. So I don't know if you can read that. Focus 1 is negative 3, 0. Focus 2 is 3, 0. So there we go. Now what's all these other lines? That's just to tell you that this plus this is the same as this plus this, which is the same as this plus this, which is the same as this plus this, which is the same as this plus this, and so on. All right, bulging vertically. Let me show you this, and then that's about it. We're going to write x squared over b squared plus y squared over a squared equals 1. So for the ellipse, I'm always going to put the x first and not the y. For the hyperbola, we will have occasion to write the y first sometimes, and I'll show you when. And again, a is bigger than b. Okay, so this is bigger than this, which means it's going to be bulging this away. So the vertices, vertex 1 is 0a, vertex 2 is 0, negative a. The foci are always along the major axis. So F1, 0, C. Focus 2, 0, negative C. Major axis, minor axis. The endpoints of the minor axis are negative B0 and B0. We don't give them any special names. Okay, I'll just show you one example of an ellipse which is bulging this way, and then I'll quit. X squared over 64 plus y squared over 100 equals 1. Okay, this number is bigger than this number. That tells me it's going to be bulging this direction. Take the square root of each of these. Square root of 64 is 8. That's the designation of b, b being the smaller number. Square root of 100 is 10. That's my a. Use a squared equals b squared plus c squared. 10 squared is 100. 8 squared is 64. 100 minus 64 is 36. So c is 6, focal distance. So from the origin, right now I'm always at the origin. So when is it not in the origin? Well, the usual, you get parentheses x plus 4 or parentheses y minus 3 or something like that. We know how that game works. You move left, right, up, and down. Okay, so up and down, I go 10. So one vertex is 0, 10. The other is 0, negative 10. V1, V2. Left and right. So how do you know if it's left or right? Just look at the letter above it. Okay, 8 is associated with x. That means I go left and right. 10, remember it's not this number, it's the square root of this number. That tells me in the y direction, so that's up and down. So 8, left and right. So I don't go as far left and right as I do up and down. So it's going to be bulging a little bit vertically. So that's negative 8, 0, 8, 0. The endpoints of the minor axis, what are they called? Nothing. 2 vertices. And the foci, since C is 6, that tells me I go 6 up, 6 down. So focus 1, 0, 6. Focus 2, 0, negative 6. All right, and that was just an introduction to the ellipse. I wasn't going to do any homework problems until next time, but this just saves me time for next time so I can get a little bit ahead. Okay, but for the rest of today, I will stop, let you work on the quiz, and we'll begin the ellipse next Monday. So let me turn this off, check the chat. Anybody have any questions, please? Others are turning loose for the quiz. Hopefully it's fairly easy. Do it at 11:59 p.m. tonight, and then have a nice Thanksgiving. No school tomorrow, no school Friday. We meet again on Monday. Okay, any other questions, please? All right, so get going on the quiz. Everybody have a nice Thanksgiving, and we'll see you next week. Okay, bye, everybody.
Thank you.
Yeah.
Thank you.
Bye.